The Leave plan of room experts has tracked down that utilizing our new 101 billion toy, it will be obviously forever before that attempt changes into a reality. On the slim chance that it goes as organized, the excursion to Proxima B will anticipate close to 20 years. So, reasonably, it will be quite a long while prior we can anticipate assuming there is sure life on that planet. The DST blushed sails of whether we are truly alone in this universe continue on through the James Webb Telescope. It has found some incredibly humanesque things far away from Earth that lead us closer to the reaction. Our mission for life beyond us has been uncontrolled throughout each human activity, so much that we have innumerable media works and hypotheses concerning this matter. Our marvel concerning our spot and importance in the universe has been dependable. It is infested inside us to look dependably for a mate. Notwithstanding the way in which comparable we may be, we could get logically closer to, in any case, the reactions we truly need. How are they actually the responses we are searching for? Or are they simply disturbing? Join us as we take apart the most moderate discoveries in the space of systems and planets on the excursion to find something we probably will not be ready to see. Lights far away. Specialists have found what could be the most critical discovery in history. Back in 2021, when the James Webb Space Telescope was intended to send off an exceptionally interesting speculative demand, a question was raised about the capacities of our innovation. The question was whether, later on, our telescopes could recognize artificial light on another planet, for example, Proxima B, the closest exoplanet to Earth. Proxima B, around 4.25 light-years away, was perceived to be impeccably locked with an extremely enduring day side and night side, like our moon. A speculative innovative upgrade for Proxima B could move power and energy from the day side to the night side using photovoltaic cells that make power from starlight. In this way, in a paper with Manis Ving as one of the scientists, it was shown that an awe-inspiring union of the day side by solar chargers could be related to future telescopes. Since the JWST was additionally developed, it would permit us to grow our quest for artificial lights on exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope did precisely that in 2024, utilizing its higher care and greater level of limits, is weighty. The JWST could have found the lights we were looking for and perhaps flung us into another huge flood of human activity. Generally, we ought to jump into the universe of planets and exoplanets to sort out how this was even conceivable. James Webb's mission explores Proxima B and its secrets. Beginning from the start of composed history, people have examined the opportunity of the universe, what we are, where we come from, and where we go. These are traditional yet shockingly badly arranged questions that humanity has attempted to answer. When we gained awareness in the era of awesome mechanical improvement, one contemplates whether we are any nearer to observing these inquiries. If you somehow manage to ask a philosopher, he could say we are right now at level 0 of understanding ourselves in the universe. Regardless, ask a space master the same question and watch him take full advantage of his energy as he races to let you know the most recent discovery people have made about the universe using their advanced devices. These instruments, though not given a ton of thought by the general population, are straightforwardly an impression of human development itself. We presently have the world expeditiously open, and it's time we push forward and get the universe readily available as well. One such method for doing so is not entirely set in stone by examiners and space specialists through the development we tackle. An explicit creation of that development is now competent for the new discovery of what may be light on another planet, light years away. Without a doubt, we're examining the James Webb Space Telescope. The James Webb Space Telescope is the creation considered out of the traditions of human attempts into space to address some ever-present questions. Are we alone? Who's out there? Where do we start and where do we end? This infrared space science device has already begun watching out for these inquiries, not getting through the reality that, at first, you could get yourself asking what Proxima B is. Proxima Centauri B, or just Proxima B, is sometimes referred to as Alpha Centauri. It is a super-Earth exoplanet and orbits an M-type star. Super-Earths could bewilder you, but don't stress. This text will settle all your burning questions. Super-Earths are a class of planets that are more massive than Earth yet lighter than ice giants like Neptune and Uranus. They are really unique, and they can be made of gas, rock, or even a mix of both. Besides, their sizes can change from 2 times the size of Earth to a few times its mass. Concerning Proxima B, it is a super-Earth and an exoplanet, meaning that a planet orbits outside the nearby planetary system. The primary possible verification of an exoplanet was found as soon as 1917. In spite of the fact that it ignited little interest, confirmation came in 1992 with the first affirmed discovery, which left subject matter experts stunned. Another exoplanet, first recognized in 1988, was affirmed in 2003. As of April 1, 2024, there are 5,653 affirmed exoplanets in 4,161 planetary frameworks. Of these, 896 frameworks have more than one planet. These well-known discoveries are surrounding an M-type star. To understand the M-type star, you truly need to figure out the red overshadow. A red is the littlest kind of star in the main sequence, hence the name. In the interconnecting region of the Sun, red midgets are by a long shot the most common kind of star viewed in the Milky Way. They have exceptionally low glow, and since radiance is one of our chief tools for planet discovery, red diminutive people are difficult to see. These unnoticeable stars have variable definitions and names depending on their temperatures and sizes. For example, M smaller people or M-type main sequence stars yield a maximum temperature of around 3000 K, subsequently getting their name. Concerning Proxima B, its mass is known to virtually be indistinguishable from 1.07 Earths. Strangely, it just requires 11.2 days to finish one circle of its star, contrasted with our 365.25 days. You can gauge the size of the star Proxima B is surrounding by taking into account the whole electromagnetic range. The star has a total radiance of as little as around 1.6% of that of the Sun. Other than in the apparent light range, its brilliance appears to diminish more. It only sparkles 5 to 6% of the Sun's splendor, emanating a much lesser amount of light energy contrasted with the Sun. More than 85% of its produced energy is infrared radiation, spinning around about 0.045 to 0.056 Australian dollars from its star. Proxima B's discovery was reported back in 2016. You could inquire as to why Proxima B, with a great many stars, planets, and worlds, is of such interest. Well, there are a few reasons that add to the astronomers' interest here. Specifically, Proxima B is the closest known star to our Sun. By definition, although 4.2 light-years is a major number to us Earthlings, in the grand plan of the universe, it is a simple blip. So, for what reason is Proxima B our nearest known star high up on the priority list? Right now, it is part of the triple star system called Alpha Centauri. Also, in any case, Proxima's shine being extremely low, the system itself appears as quite possibly one of the most brilliant divine bodies in the night sky, just behind two others called Sirius and Copus. In any case, the most beguiling thing about Proxima Centauri B is that it could genuinely be habitable as it falls within the livable zone. The possibilities surrounding the star are infinite, and hence space specialists have undertaken the task of investigating the depths and limits of the star's viability. Likely, that is where the James Webb Space Telescope comes in. The four primary objectives of the JWST are to search for light from the first stars and systems that formed in the universe after the Big Bang, focus on the universe's advancement and development, figure out star and planet development, and center around planetary frameworks and the beginnings of life. As the JWST continues its assessment of the said exoplanet, we move closer to the zenith of these missions, from looking for exoplanets to searching for extraterrestrial life. So, what precisely is said one could inquire, taking into account that people have forever been a curious species, investigating and getting into literally everything that moves and doesn't move. It seems okay that a mission like this would show up on such a massive scale. Imagine that God has formed an unbelievable gigantic venture. In any case, with a hint of gold, we are blessed with being the ones watching for flags. More specifically, electromagnetic mumbles from human advancements past whatever we might ever imagine. SETI, short for the search for extraterrestrial intelligence, looks like the world's most high-stakes game of Find the Stowaway, with our group as the searcher and the immense universe as the seemingly infinite hiding spot. It is one of those fields where researchers are like high-level Sherlocks, tuned into radio waves and scouring for that subtle, we are not alone signal. This galactic sleuthing began in the 1960s. Frank Drake, an unmistakable astrophysicist, was among the first to perceive radio transmission from the stars. It was a striking moment. Anyway, no outcasts showed up at his door, at least not yet. Searching for something this colossal takes patience and can traverse quite a large number of years, sometimes even more. Very few decisive extraterrestrial signs have been found, but despite these endeavors, the energy continues to grow as the James Webb Space Telescope keeps inspecting exoplanets like Proxima B. An entire field of hope is arising. Will we unintentionally find certified confirmation of extraterrestrial life? Or will we just experience shocking signs just outside our capacity to fathom, giving us more questions than answers? The discovery of lights, in fact, could mark the following part of mankind's immortal interest, where curiosity and progress converge into one gigantic, invigorating space story. So, let's continue looking, hoping to find confirmation that we are not genuinely alone. The discovery of lights from far-off exoplanets like those possibly seen on Proxima B could be a huge move toward responding to one of mankind's most significant inquiries. Are we alone in the universe? As the Webb Space Telescope continues to inspect the skies, its revelations will undoubtedly ignite more discussions, examinations, and maybe challenges to our crucial understanding of life, intelligence, and the nature of the universe. The ramifications of these disclosures expand a long way beyond simple curiosity. They carry the possibility to reshape our philosophical and scientific frameworks. For instance, if we somehow happen to confirm that Proxima B or another exoplanet harbors some type of life, it would force us to rethink our position in the universe. Could life somewhere else develop in ways similar to our own? Or would it present a totally new type of existence? Would it follow similar groundbreaking paths? Or would its science and consciousness challenge all that we know about life on Earth? Regardless of whether we fail to track down direct proof of intelligent life, the mere fact that we could detect artificial signals or lights from far-off worlds would still have significant ramifications. It would imply that intelligent human civilizations are out there, potentially capable of adjusting their surroundings in ways that are distinguishable from our vantage point. This would confirm that intelligent life is not a rarity but perhaps an inevitable result of specific conditions in the universe. Anyway, it's essential to remain grounded and wary despite such disclosures. While the potential for finding life is thrilling, it also raises the question: what happens next? How might we respond to the confirmation of extraterrestrial life? Would we approach it with respect, curiosity, and scientific diligence? Or would the discoveries spark frenzy, fear, or even political fights? History has shown that mankind's reactions to new discoveries, particularly those that challenge deeply held beliefs, can be unpredictable. We should also consider the moral aspects of our curiosity. If we do indeed find proof of life, particularly intelligent life, what's the significance for our responsibility as stewards of our own planet? What moral considerations should guide our interactions with different forms of life, whether microbial or advanced? These are not questions that can be answered easily, and they will likely be a central part of the discussion as we venture further into the universe. By the way, the search for life beyond Earth, driven by instruments like the James Webb Space Telescope, represents an exciting junction of science, philosophy, and mankind's future as we venture further into space and push the boundaries of exploration. The discoveries made by the James Webb Space Telescope and other advanced instruments open up entirely new realms of possibilities. The idea that we might detect signs of life on distant exoplanets like Proxima B isn't just a scientific pursuit. It's a philosophical journey that challenges our understanding of the universe and our place within it. What if we discover not only signs of life but evidence of civilizations that have long existed before us? What implications would this have for our self-perception and our sense of importance in the cosmos? The technology that allows us to observe far-off planets and their potential for life is evolving rapidly. Instruments like the James Webb Space Telescope are designed to gather data from distant stars, galaxies, and planetary systems, providing unprecedented insights into the nature of these worlds. In particular, the search for exoplanets located in the habitable zone, where conditions might support life, has captured the imagination of astronomers. Proxima B, situated so close to Earth in astronomical terms, is one of the most promising candidates for further study. Its position within the habitable zone of its star increases the likelihood that liquid water could exist, a crucial ingredient for life as we know it. However, finding life, if it exists, on Proxima B or elsewhere will not be the end of the story. The next challenge will be interpreting the data. Are we truly detecting artificial signals or signs of intelligent life? And even if life is confirmed, how will we manage the immense ethical, cultural, and scientific challenges that come with this discovery? If there are other intelligent beings out there, how will we communicate with them? What would we say? And how would we ensure our actions are in line with the responsibility that comes with such knowledge? These questions point to the profound impact that such discoveries could have on human civilization. The pursuit of understanding life beyond Earth is not just about searching for answers. It is about shaping the future of humanity in ways that we can hardly predict. Our continued exploration of the cosmos will not only enhance our scientific knowledge, but also deepen our understanding of what it means to be human.